For this lesson, we're going to look at parent functions and how to translate their graphs up and down and side to side. So first of all, there's an opening problem. Let's review about just linear equations. If you could find the equation of this, the line that goes through these 2 points in standard form. So pause the video, try the problem, and then come back and take a look at the solution. Now that you've tried the problem, let's do this. Let's go ahead and find the slope. So the slope of this one is you take the difference of the y's over difference of the x's. So you get 8 over 1 plus 3 minus the negative is 4. So it gives me a slope of 2. Now that we've got that slope, let's go ahead and put it into point slope form, which is y minus y sub 1 equals the slope times x minus x sub 1. So we're going to pick one of these two ordered pairs. I'm just going to pick this first one and this slope and put it into this equation. So I'm going to have y minus the y value of the point I picked equals the slope times x minus the x value. Now if you'd picked the other one, it would look different here, but when you simplify it, it will look exactly the same. So y minus 5 equals 2x minus negative is a plus, so 2 times positive 3 is plus 6. And then I'm going to add 5 to both sides to get y equals 2x plus 11. This would be the answer if I asked for it in slope-intercept form. But now let's put it into standard form. We want to get the x on the other side, so we subtract 2x from both sides. And then we can't have it start with a negative, so in standard form we multiply every term by negative 1. So we get 2x minus y equals negative 11. There is our equation in standard form of the line that goes through those 2 points. Now, what I'd like to do is I'd like to try the one on the right here, where it gives you a graph. And on this graph, I'm going to highlight 2 points. It has 0, 5, and it also has the point here, 3, 3. There are other points on the line, but I'm going to highlight those 2. Now, the reason why I highlighted those 2 is you can now use that information to come up with the equation of the line. So the first thing we do is recognize that we can do the slope. If we go down 2 units from 5 down to 3, what we get is we get a negative 2 coming down here, and then when we go over 3 units, that's a positive 3, so my slope is equal to negative 2/3, rise over run. You can find that by doing 3 minus 5 is negative 2, 3 minus 0 is equal to 3, and so we get negative 2/3. Now we want to put that into y equals, we'll try slope-intercept form this time. Y equals negative 2/3 x, that's the m, plus the b. We need to figure out what the b is. Now we have 2 options here. We could put in either ordered pair for x and y and calculate b, or recognize that the 5 is the y-intercept. This means b is equal to 5 because that's where it crosses the y-axis. So our equation is y equals negative 2/3 x plus 5. Now we're going to multiply everything by 3 to get rid of the denominator because we can't have fractions in standard form. So we're going to have 3y equals negative 2x plus 15 when we multiply that by 3 as well. And now bring the x on the left side for standard form. So 2x plus 3y equals 15 is my equation in standard form. So there's both of our problems where we have the equation of the line from information from points or from the graph. For this next part, we're going to talk about specific parent functions and what they look like. So what we're going to do is I'm going to look at these 4 different types: absolute value, quadratic, identity, and constant. Now parent functions, again, what that means is we have a general look to certain types of functions, and we want to know what that look is and then how the graph moves. So to first of all, let's start with absolute value. absolute value, if we have the absolute value of a linear expression on the inside, it looks like a V. That's because it's a positive value here, and then whenever it tries to go negative down here, absolute value makes it a positive y value, so it bounces it back up. Over here, this is the quadratic. The graph is a parabola, and the idea is when you have a square, it curves that graph, but again, the square also makes it positive and brings it back up to the positive side. Now, identity is where we have just a line, y equals x, f of x equals x. That line is a slope of 1. We could change the slope for other lines, but the general look of the function is that it looks like a line sloping up or sloping down. We also have when it's horizontal for a function. Vertical is not a function, so this type is when we have a constant, f of x equals some constant number. So as an example, if this were a 4, where this crossed the y-axis, this would be y equals 4, or f of x equals 4 for that. Now what we're going to do is take these graphs and we're going to move them to the side or move them up and down as part of these graphs. When we do that, when we move the graph up or down, it's called a translation. Or if we move it side to side, left or right, that's called a translation. Now, if we flip the graph, let's say we take this V and flip it over, that's called a reflection. So if we're going to flip the graph, flip over an axis, that would be a reflection. So taking this parabola and turning it over like that, or if we take and we're to take this and flip it over the axis to be the other direction. Okay, so what we'll do now is this is the general look of what the functions are. Let's talk about specifically how they move. There's a lot of detail here on how we're going to graph it. So I want to give you not only the detail and a description, but I'm going to give you an example just so you can kind of see what happens. So first of all, if we take whatever function it is, like here, this function is x squared. So when I say outside the function, if I write this out then as f of x equals, and let's do maybe outside the function, f of x equals x squared plus 3. Notice that that's outside of the square. What that does is it translates it up if we have k is positive. Okay, this number here, k is positive. It translates it down if k is negative. So if that had been a negative 3, it would have moved it down. So when I look at the graph of this, my general form, my look of x squared, remember, is just looks like this for the family of functions. And so if I have a 3, it just moves it up to 3 and gives the parabola up 3 units. But it looks the same, just moved up 3 units. If this had been a minus a number, it would have moved it down that many units, okay? Now, let's say that we've got instead here, let's say we've got the k on the inside of the parentheses here. So that would be, for instance, if we had f of x equals x plus 3 inside the function, okay? Now here, it's going to move it left or right, but it's going to move it the opposite direction we would expect. So it translates it right if k is negative, and it translates it left if k is positive. So this one, because k is positive, it's going to move it a negative 3 units over. It's the opposite of what you expect. So I'll put that down here. Opposite of the number. Okay? So here, this graph, remember my base function looks like that parent function there. It's going to move it over to -3 and do my graph over starting with the vertex over there. So whatever that number is in there, you go the opposite of that with left or right as part of that graph. Now, that's the translations. When it's outside the function, it moves it up or down. When it's inside the function, like the square or inside the absolute value, then you're going to move it side to side, but the opposite of what you have. All right, let's look at outside the function with the negative. Now this is where we get the reflections. So if you have a negative in front there, what it does is it reflects over the x-axis. So it flips it down. So this would be, for instance, if we had f of x equals the opposite of x squared. Notice it's outside of the function, it's not inside with the parentheses. And so what that would be is, it would take this graph and it flips it over the x-axis and makes it go down like that instead. Okay, so that's an example of what that one would look like. Okay, and then this last one, it's not really obvious in what we're going to do here. In fact, it's going to look exactly the same because this is on the inside. This would be, for instance, if we had f of x equals, if we put the opposite of x inside the square. Now, if we did that, it actually reflects it over the y-axis. So if you were to fold the graph, that's what reflection means, fold this parent function on the y-axis like this, notice this would just be folded over on this, that over there. It would look exactly the same in this case. Not all reflections are like that, but with these parent functions, oftentimes that happens with the inside part. So this would be flips it over the middle. Okay, to the side. Okay, so you take it, flip it to the side by flipping it over the middle. All right, next I want to do some examples for you of these. Here are the examples. First of all, we're going to do an absolute value one with a -2 in the middle. Remember, these are the parent functions where they go through 0, 0 of this is y equals x squared, absolute value of x, this is y equals x squared. So this one, when we've got that x minus 2, all it does is it takes this graph, because it's on the inside, you do the opposite of what you expect. So we're going to go out to +2, and then we're going to just draw our v like that. So it's going to go like this. And what I'll do is I'll show you in a future class how we can put this into your graphing calculator. But for now, if you're unsure, what you can do is set up a table. And since 2 is at the middle for my x, I'm going to go with values less than it and greater than it. And if I put in 1 into this, 1 minus 2 is -1. Its absolute value is a +1. If I put in 0, 0 minus 2 is -2. Absolute value of it is +2. And then put in 2, 2 minus 2 is 0. 3, 3 minus 2 is 1. Its absolute value is 1. Put in 4, you get 4 minus 2 is 2. Absolute value is 2. And then you plot all those points. Okay, so that would give you the graph in terms of a table. Now this one, we did already on the other one, but I want to just emphasize it. If you've got this negative on the outside of the absolute value, you take this one and you go ahead and turn it over, and it just goes upside down. It goes through the same points as it would up, but just the negatives. Now what if I made this instead y equals the opposite of x squared, and then I'm going to go ahead and subtract 3 from it. Now that's on the outside. It's going to take this graph here, instead of being right there flipped over, it's going to flip it over, but also what it's going to do is move it down 3 units. So what I'm going to do is have down here at -3, it's then going to be the graph move down 3 units. Okay, so that's just a kind of a bonus as part of that. And then this last one here, remember this thing here, let's just talk about how these things translate it. The number on the outside moves it up or down, so this will say up 4, and this one on the inside moves it left or right, but the opposite of what we expect, so this moves it -1 units in the x direction, so that would be to the left, okay, 1 unit. Okay, so when we draw this graph, we're going to think about this parent function, the v, and we're going to go up 4 units, so 1, 2, 3, 4, and we're going to go to the left 1 unit, so -1 here, and we're going to have the vertex of it moved up 4 and over 1, and the v then just goes right from there. And again, if you're not sure, set up a table, an XY table. We could put in -1 and put in some values around it. I'll just do a couple here. Oops, we'll do 0 then. So if you put in -1, -1 plus 1 is 0, plus 4 is 4. There's my -1, 4. -2 plus 1 is -1, absolute value is 1, plus 4 is 5. So that gives me at -2 here, it's up here at 5. Okay, and then put in 0, 0 plus 1 is equal to, okay, I'm gonna make this change a little bit, go right through that 5. Put in 0, you get 0 plus 1 is 1, absolute value is 1, plus 4 is also 5. And so I get my v moved up 4 units and to the left 1 unit. Okay, so what I'd like you to do now is pause, reflect on what it is that you learned here, what were the main points of this lesson, and then you can start working on your homework.